In this class, we're going to study the examples at the end of Article 52 in our Algebra 1 textbook. If you look on the Study Center, this is listed as Lesson 4. So this is Lesson 4 of Modern Algebra in the Classical Liberal Arts Academy. And we're going to do all of the examples at the end of Article 52. So if you follow this class, if you pay attention and take notes, you're going to see how to do all of the exercises that are there in the book, and you should be able to put them together and submit them with the lesson assignment. So pay attention. We'll go through every one. If you have any questions, you can ask. But I think that you'll see that these things are pretty clear, and they'll test. These exercises will test whether you understand the things, the definitions and rules that we've studied so far. So let's get ready for this class. Let's prepare our notes. Put your name and date at the top of your paper. This is Modern Algebra 1. Modern Algebra 1, and this is labeled as Lesson 4 in the Study Center. Article 52, exercises. They're actually listed as examples. They're named examples, but we'll call them exercises. And they're going to put to the test your knowledge of the different definitions and explanations that we've studied so far, okay? So we'll walk through these. If you have them on your computer here, if I write the exercise up on the board, just check for me and make sure I get everything right, because it's a little difficult for me to read some of these, and just double check when I'm copying down these exercises. Make sure I've got all the details right. Let me see if I can zoom in a little bit. Okay? So we're going to work through these exercises. You can follow along in the book. This is on page 24 of the document, or you can just go to Article 52, down to the examples. So our book tells us the following examples are intended to exercise the learner in the use and meaning of the signs. Copy each example on the blackboard. I'm going to do that, and then express it in common language. So we're going to do that first. Then it says, let the numerical values be found on the supposition that A equals 4, B equals 3, C equals 5, D equals 10, X equals 2, and Y equals 6. So the first thing that I'd like to do here is just write those values up at the top of the board so we can refer to them. So A equals 4. Can you read them to me? B equals? 3.
C equals 5.
D equals 10.
X equals 2. And Y? 6. Okay. So we'll just keep that up there for reference. Just double check that. A is 4, B is 3, C is 5, D 10, X 2, Y 6. All good? Okay. So now we're going to go through these exercises in our book. We're going to plug in those values for the different letters that are given in these expressions. But before we solve them, and remember, the solution is not just finding answers. A solution is an explanation of how to find the answer, right? Modern math classes that let kids find the answers don't teach mathematics, and that's why kids struggle. You can cheat on a math test where all you have to do is get the right answer. And that's why kids cheat. When I was in high school, I cheated because all I had to do was get the answer. And I really had no idea what we were doing because nothing was explained. We didn't have a textbook like this that taught us all the definitions and rules and principles. So we want to make sure that we don't simply find the answer. The answer is given to us in the book. That's not a big deal. Nobody cares that you can find the right answer. You can get lucky, right? You can get lucky. There's an old saying that says, a broken clock is right twice a day, right? A broken clock is right twice a day because that time comes twice a day that the clock shows. So who cares if you can get the right answer? You may just get lucky. Honestly, you may do something that just happens to work and get you to the right answer, but with another problem, it won't get you to the right answer. So nobody cares if you get the right answer on this or that problem. You have to be able to give a solution, and the solution is an explanation of how to find the right answer. All right? So the first problem we have here is C plus D minus B. And I've already read it. The quantity C plus the quantity D minus the quantity B. Okay? And if you want to be even more complete, you'll say, what is the sum of the quantity C plus the quantity D minus the quantity B? All right? So now what we need to do, we're given the values, and we simply need to replace the letters with the values. So if C equals 5, and D equals 10, and B equals 3, we just have basic arithmetic. 5 and 10 are 15, minus 3 makes 12. Check the correct answer. Do we have the correct answer? It's that simple. Okay, this is I'm telling you, modern mathematics is not where the smart people are. This is not hard. Students act like they're brilliant because they can do modern math, because there's just no other courses in the curriculum that are more challenging. If you study classical reasoning and ethics and classical Latin and Greek and then you come to this is easy. All right? We just have to follow the rules. There's nothing to do. You don't even have to think a lot to solve these problems. You just have to follow the rules. Number 2, we read 4 times A minus X. 4 times the quantity A minus the quantity X. So we're going to take 4, and what does it mean when we have 4A? What does that mean? 4 times A. And we can show that by just writing the quantity in parentheses next to it. A is 4. So we're going to have 4 times 4 minus X equals 2. Now, before we go any further, remember, and this is the most important lesson in algebra. This is such a simple lesson, but almost every student I know who studies algebra doesn't learn this lesson, and it causes them trouble their whole life, at least in algebra classes. Remember that we took a whole lesson talking about monomials. We talked about terms, right? What is a monomial? Who can tell me? I don't care if you have the exact words. Make an effort to tell me what a monomial is. What is a monomial? Anybody? What is a monomial?
Isn't that one of those one that has 2?
No, that's...
C plus D.
Is it one of the ones that check?
No.
C plus D.
No. So you're not paying attention. You don't know what a term is. You don't know what a monomial is because you didn't review your notes. And you will get confused on these problems. You'll get stuck on these problems because even though I told you 784 times that you have to know what a term is, you didn't listen, and now you're going to fall right into the trap that everybody else does and say, I'm not good at algebra, which is ridiculous because algebra is not even difficult. A monomial is a quantity. A term is a quantity not separate, that doesn't I just had mental lapse. A term is a quantity that doesn't contain, that's not separated by plus or minus, right? So when we look here, we have one term. I'm just going to put it in a box. Ready? This is a term, and this is a term. Do you understand that? Please look up here. 4a is a term, and x is a term. They're separate terms because they're separated by plus or minus. Don't you remember that? Right? Terms are separated by plus and minus. C plus D plus minus B. How many terms do we have here? What do you call a quantity, an expression that contains three terms? Well, yes, but even more specific, three terms. Polynomial just means more than one. What do you call an algebraic expression that consists of three terms? No, trinomial. Okay? This is an example of a trinomial. Three terms. 4a minus x, how many terms? Two terms. So the first thing we're going to do, this is why this is important. Let me show you how you can screw this up. 4a minus x, right? And I can ask you, what does 4a mean? 4a means 4 times a, right? So if I write 4 times a minus x, and then I say a equals 4, so I have 4 times 4 minus 2. How do I figure out what order to do this in? Do I just start on the left and go to the right? How do I know what order? Because I have a multiplication problem and a subtraction problem. How do I know what to do first? Is 4 times 4 minus 2 the same thing as 4 times, what's 4 minus 2? Is 4 times 4 minus 2 the same thing as 4 times 2? So you can't just do whatever you want here, right? You have to know the order in which these things have to be done. Now, you can take a math class and they can teach you all kinds of complex rules for how to figure out what needs to be done. But there's a very simple rule. This here, 4 times a, is one term. And this is another term. So what we want to do when we solve a problem like this is we want to find the value of each term. So if 4a is equal to 4 times a, and 4 times a is equal to 4 times 4, what is the value of this quantity? 4 times 4? 16. So we find the value of this term, and all of that confusion is gone. Do you understand that? You have to be able to identify terms because you have to find the value of each term by itself. That's the key. Do you understand that? You have to find the value of each term first, and you'll see in future questions how this gets more and more complicated. So the value of this term is 16 minus x equals 2 equals what? 16 minus 2 equals 14. That's the answer to number 2. Is that the right answer? Yes. Okay? You're going to see what I'm talking about with terms as we get into future problems. You're going to see you'll get the wrong answer if you don't do what I said. Number 3, negative 3ax. Negative 3ax. What does this mean? What does negative 3ax mean? Who can read that in words for me? Negative 3ax. What does this tell us to do? Good, try.
X times a, negative 3.
Negative 3 times a times x. Okay? Negative 3, that's term, oh no, I don't want to say term. Negative 3 times A times X. That's what that tells us. One of the reasons why it's helpful to use dots for multiplication is so you don't confuse them with X's in algebra, right? It'd be pretty confusing if I went like this, wouldn't it? That's why we don't, you can use dots instead of X's. So negative 3 times A times X. Negative 3 times A equals 4, right? Times X equals negative 3 times 4. What's 3 times 4? 12. Negative 12. Negative 3 times 4 is negative 12. What's 12 times 2? 24. Negative 24. So the answer is negative 24. Is that the right answer in the book? Yes. I've seen students at this level struggle and not know how to work with negative numbers. If you don't know how to work with negative numbers, it's very simple. Look, I'll tell you right now, very simple. Watch this. You might want to jot this down. I've seen some students who get to Algebra 1 and they don't understand negative numbers. If you have negative 3 times 4, that's equal to negative 12. A negative times a positive makes a negative product. Okay? And it's very simple to understand. Think about it. Negative $3. Let's say you owe me $3. You owe me $3, so you're negative $3, right? And tomorrow you owe me $3 more, and the next day you owe me $3 more, and the next day you owe me $3 more. So you have negative 3 times 4 days. You're negative $12. Do you understand that? Yes or no? Okay? A negative times a positive makes a negative product. Negative 3 times negative 4 equals a positive product. And of course, 3 times 4, 2 positives equal a positive. That's all you need to know about multiplying negatives. A negative times a positive makes a negative product. You see that? All other products are positive. Okay, so here we had negative 3 times 4. So what's the answer? Negative 12. And then we had negative 12 times 2.
24.
Negative 24. Good. Negative times a positive makes a negative product. Okay, so if you've never seen that before, it's nothing complicated. This is all you need to know. A negative times a positive makes a negative. Everything else is positive. Okay? So that's our answer for number 3. Number 4. The problem in the book is 6a squared x. Okay? We have to find the value of this algebraic expression assuming these values. We have to find the value of this expression. Who can tell me what this means? Who can translate this from algebra into English? Go ahead, try.
6 times A times 2.
No. This is not times 2. This is not A times 2. What is that?
6 times A to the second power.
6 times A to the second power. What does A to the second power mean?
Times itself.
Right, times itself. 6 times A, keep going. times x. 6a squared x, that's the easy way to say it, but what it means is 6 times a times a times x. A power is a number multiplied by itself that many times. Right? So we have 6 times a times x. And look at this for a minute. The hard part of algebra, the hard part is getting from here to here. Understanding what this means is the hard part. Once you can basically translate this and understand exactly what it means, now it's easy. This is baby work, right? What do we have? We have 6 times a equals 4 times a 4 times x 2. We just have some multiplication to do. 6 times 4. 6 times 4, 24. 24 times 4. 24 times 4. No, that makes... Hold on. 96. 24 times 4 is 96. And 96 times 2. 96 times 2. 192. Is that the right answer in the book?
Yeah.
Yes. Who can explain to me what this means? 6a squared x. Can you explain what that means? 6a squared x, what does it mean? You want to try again?
Yeah.
Go ahead.
6 times a times itself.
Right.
Times x.
Right. 6 times a times x. Okay? And you would read that as 6a squared x. Got that? You're learning a new language. That's why if it's clumsy when you get started, this is a language. You're just learning how to express ideas just like you're learning a new language. Right? We should expect that it's going to be slow at first, but you're going to get more comfortable as we go. 6a squared x. This is a power. A squared means a times a. Pay attention. Pay attention. You could learn this stuff. It's not hard. Pay attention. You have to work. Study is work. Just like digging a hole or raking leaves or shoveling snow, study is work. You either do the work or you don't do the work. It's not a mystery. There's no like magic fairy dust that gets sprinkled down on you and all of a sudden you understand things. It's work. All right, so we solved 6a squared x. Number 5. Number 5. This gets a little more complex. But when we see things get more complex, we just take our time and break it down into simple parts, and then we solve simple parts. We have ay over b, plus cd over x. You have an algebraic expression. What's the first thing you should look for? I've told you 787 times what to look for. What's the first thing you should look for? No. What's the first thing you should look for? You should identify the terms. I'm sorry if that's a letdown. You were hoping to have some exciting thing. You have to identify the terms. This is an algebraic expression consisting of how many terms? How many terms are here? 2 terms. And listen, if you guys struggle with this, I'm telling you, this is what students don't learn in algebra. Okay? The first thing you look for when you look at an algebraic expression, you look to see how many terms there are. And you think of the terms You think of the terms as separate quantities. Do you understand that? Do you understand that? You treat the terms as separate quantities. So we're going to treat this as one quantity. This is one term. And this is another term. Other than just guessing and getting lucky, how do I know that these are the two terms? How do I know that there are two terms?
Because it's added by plus.
They're separated by a plus or a minus sign, right? Okay? So we have two terms. So we're going to figure out what the value of this term is, and then we're going to add that value to the value of this term. We're going to keep these terms separate in our minds. We're going to keep this complicated problem, we're going to separate it into its parts and keep it simple. You understand that? All right, so we have a y over b. What does that mean? Go ahead.
A times y.
A times y divided by b. That's what that means. A times y, find the product of a times y, and then divide that by b. So let's do that. A times y. A equals what? A equals 4 times y. 6. Divided by b. What is b?
3.
What?
3.
3. What is 4 times 6?
10.
Are you serious?
24.
No, stop. Don't say things without thinking. You don't think that 4 times 6 is 10. And I want you to understand. I know that you don't think that 4 times 6 is 10. You don't think that. Nobody thinks that 4 times 6 is 10. But you answered without taking time to think. That's the problem. Do you understand that? You were so worried about saying the answer first that you didn't think to find the right answer first. We talked about that in composition class. Have something to say, right? That's the first rule of expression. Have something to say. Do you think that 4 times 6 equals 10? No. So don't try to blurt out an answer. Think. Even if someone says it first, if he says the right answer first and you think the right answer in your head, but it takes you too much time and you don't get to say it, who cares? You got the right answer, right? It doesn't matter. 4 times 6 is what? 24. And 24 divided by 3 is what? 24 divided by 3. So let me ask you this. If you struggle at this level with math, is algebra causing your trouble? No, hold on. Is algebra causing your trouble? Is algebra the problem here? No, don't blame algebra. Don't blame algebra. Don't pretend that kids who know algebra are some kind of wizards. You got the multiplication and the division questions wrong. That has nothing to do with algebra. Do you understand me? What am I always telling students? I'm always telling students you struggle in math because you don't have your arithmetic facts mastered. Right? If you don't have the arithmetic facts mastered, you will struggle in other math classes, and it has nothing to do with those math classes. It has nothing to do with algebra. Students get addition questions wrong. Students get multiplication questions wrong, division questions wrong. They don't remember what exponents mean, and they get powers wrong. And that has nothing to do with algebra. Do you understand that? And then they walk around saying, I hate algebra, I'm not good at algebra. It has nothing to do with algebra. 4 times 6 is 24, and 24 divided by 3 is what? 8. So this term, this quantity here, is equal to 8. I'm going to write it down here. 8 plus this term. How do we read this term? What does this mean?
C times A divided by X.
C times D divided by X. The product of C times D divided by X. So what do we have here? What is C? C equals 5 times
10.
D equals 10 divided by X. 2. What's 5 times 10? And don't say 15. What's 5 times 10? 50. And what's 50 divided by 2? 50 divided by 2. 25. What's 8 plus 25? This is not algebra. This is arithmetic. 33. Is that the right answer in the textbook?
Yeah.
Yes. What mistakes did you make on these problems? Algebra? Were there any algebra mistakes on these problems? No. The problems that students make in algebra class are owed to the fact that they haven't mastered arithmetic. It has nothing to do with algebra. Algebra is simple. Okay, so we're through number 5. We're going slow here, but hopefully we're making some long-term progress. Not much short-term progress, but we'll take no short-term progress for some long-term progress. Okay? Moving on. Problem number 6. I think that says 3a squared plus 2cx minus b to the 3rd power. This is number 6. Problem 6. 3a squared plus 2cx minus b to the 3rd power. So who can translate this for me into words? Go ahead, just slow. I want you to learn to think, and then speak. It's not smart to blurt out answers if they're wrong. Think. Go ahead. Read this to me. I'm going to write what you said. Go ahead.
3 times A to the 2nd power
Okay.
plus 2 times C times X minus B to the 3rd power.
Good. All right. Before we even do that, what's the first thing we should have looked for? How many terms there are. Okay. How many terms are there? 3. Right. Here's term 1. Here's term 2. And here's term 3. So now let's go back over this. How do we read this term? 3 times a to the 2nd power. We can also say 3a squared. Right? What does that mean? What does a squared mean?
A times itself.
A times itself. Good. So this is equal to 3 times a times a. And that's our first term. So we want to keep that separate in our minds. Plus our second term. What does this mean? Try it.
2 times C times X.
Good. 2 times c times x. Minus a third term. What does this mean?
B to to the second power.
No, it's not b to the second power. That's a 3. Third power. Okay, so that's right. B to the third power. You see these mistakes we make? I want you to understand this because this is important. You see these mistakes? You say something wrong, and almost as soon as it comes out of your mouth, you know it's wrong. Right? In math, those are called careless errors. Careless errors. Okay? Careless errors. And look, that's the kind of stuff that A students don't do. Right? If you're going to get a 100% on an exam, look at me. If you're going to get a 100% on an exam, you can't make a careless error. You have to be careful, especially in mathematics. You know, we study ethics, and in ethics we learn that we can't study ethics with the same accuracy that we have when we study mathematics, right? You know how we talk about that, right? We have to adumbrate. We have to make a sketch. We can't talk with the same accuracy. Well, when you're in math class, you have to be accurate. And if you make a careless error, the whole problem will be wrong. And a careless error could mean you write the problem sloppy, you don't line up the columns when you add or multiply numbers. Those kinds of dumb little mistakes that we make, that's most of what kids get wrong. When I'm grading assignments, that's the kind of stuff kids get wrong. And do I think that the kids don't know how to add 2 plus 3? No, I know they know how to add that, but they're careless. So these mistakes that we're making, look at me. I want to make sure you understand this. These mistakes that we're making, these are the mistakes that get people bad grades in math classes. And you have to learn to be more careful. Okay? Be more careful. This is b to the third power. What does that mean? What do we have to do with b?
B times itself.
B times itself.
3 times.
3 times. Good. So b times b times b. Okay, so now we have this broken down a little bit. We took something that looked complicated and we translated it. We translated it into something that's easier to work with. So now we just want to find the values of each of these terms. This term here we have 3 times a. What's a? A equals 4 times 4. So we have to find the value of this term if a equals 4. What's 3 times 4?
12.
What's 12 times 4? Think first. 48. So the value of this term, if a equals 4, the value of this term is 48. Plus 2 times, what's c? 5 times x. 2. What's 2 times 5? 2 times 5 is 10. 10 times 2 is, the value of this term is 20. Minus this third term. What's the value of b? 3. 3 times 3 times 3. What's 3 times 3?
9.
9. What's 9 times 3?
27.
27. Now we have simple arithmetic. What's 48 plus 20?
68.
48 plus 20 is 68. And what's 68 minus 27? What's 68? Now stop. What are you doing wrong right now? You're looking at these numbers as 68 units and 27 units. What do we learn in arithmetic? That's not how our number system works. We have 6 tens minus 2 tens and 8 units minus 7 units. It's very simple arithmetic. 6 tens minus 2 tens makes 4 tens. 8 units minus 7 units.
1.
What's the answer in your book?
41.
41. That's the right answer. Now when you're getting started, if I was going to solve this problem by myself, I wouldn't do all this stuff. Do you understand that? A lot of this, I would just do this in my head. And eventually, you'll just start doing this stuff in your head. You'll know what this means. You won't need to do this. You'll just quickly say, oh, b times b times b to the third power. You might even memorize the powers. You might memorize that 3 to the third power is 27. You understand? But it's like learning to play the piano. You start by just practicing slowly. You practice slowly and make sure you get everything right. Practice slowly, make sure you get everything right. And then you keep practicing and repeating, and you get faster and faster and faster without making mistakes. It doesn't matter if you're fast and you're full of mistakes. That sounds terrible. You have to start slow and not make mistakes. And over time, you'll get faster and faster. All right? So 3a squared plus 2cx minus b to the third power, or b cubed. If a equals 4, b equals 3, c equals 5, d equals 10, and so on, the value of this expression is 41. Okay, that's number 6. Number 7, a times a plus b. This is our first problem with parentheses, right? Parentheses are one of the signs of algebra. This is our first problem with parentheses. What do parentheses mean? Let's not be dumb. Let's go back and look at the definition. I see parentheses in this problem, and what I told you is you have to go back and look at the definitions. So we see parentheses, and if I was to ask you, what are parentheses? Do you know what the parentheses show us? Let's go back and look. What article did we study parentheses in? No guesses. Let's not be lazy. Let's go back and look. Article number 48. In Article 48, we learn that a parenthesis is used to show that all the included terms are to be considered together as a single term. A parenthesis is used to show that the terms inside of it are to be considered as a single term. So did your textbook, did the author explain this to you? Yes, he did. Don't blame the textbook. Don't blame the author. He explained it. You have to make the effort to go back and look it up. All the answers are in the book. This is not hard. So we're to treat this expression here, a plus b, we're to treat it like one term. So what we have is basically a times the term, or times the two terms, a plus b. You understand that? All right? So the first thing we're going to do is we're going to find the value of this term. The value of this term is equal to a plus b. What's a? A is 4. What's b? B is 3. So what's the value of this term? 7. And we have to multiply it by a. So what is the value of a? 4 times the value of this term, 7. What's the product? 4 times 7 makes 28. So when we're given an expression in parentheses, we're to consider that as a quantity by itself, and we're to find the value of that quantity first. So far we've done 7 problems. and we found the correct answer each time, right? The mistakes that have been made have been careless errors and simple arithmetic fact errors. True or false? We haven't, excuse me. We haven't had much problem reading algebra, right? This isn't that hard. That hasn't been the problem. Even when we have found something new, we've been able to look back at our definitions and see what it means. That's not hard. Most of the problems have been simple careless errors, arithmetic errors, and like I said, if you saw this and didn't go back and look it up, that's just laziness. That's laziness. Don't blame algebra. Algebra is easy. These other problems have nothing to do with algebra. Let's go on. We'll do one or two more. Number 8. Hopefully you're getting these things down, because if you do, you'll know how to solve the problems and be done with the exercises. Sure hope you're paying attention. Question 8, or exercise 8. We have A plus B times A minus B. A plus B times A minus B. And this is where students who don't listen start getting all the questions wrong. What's the first thing that we should look for? Terms. How many terms do we have in this expression? Be careful. 3 terms. What's the first term? A. What's the second term? B times A. What's the third term? B. We could say negative B, but we'll just say B. Okay? So we're adding the first term plus the second term and taking away the third term. A plus B times A minus B. What's the value of this term? A equals 4. I'll keep it in a box to show that it's a term. Plus, what's the value of this term? B times A.
7.
12.
It's just laziness. It's just laziness. This is like a plague in our generation. Nobody in the whole entire world thinks that 3 times 4 makes 7. Nobody thinks that who's above 8 years old. It's just lazy, careless, and that's a virtue problem. That's got nothing to do with algebra. That's the vice of sloth, just lazy and careless. What's B times A if B equals 3 and A equals 4? What's 3 times 4? 3 times 4 is 12. Minus, what's the value of B? It's told you right there. 3. Who can add 4 and 12? 4 and 12 are 16 minus 3, leave. What's the answer in the book? 13. That's the correct answer. Laziness and arithmetic errors. Not algebra. Not algebra. Algebra is easy. Most students in America struggle with algebra for 2 very simple reasons. They've never learned arithmetic, and they're just lazy. Number 9. We have A plus B in parentheses next to A minus B in parentheses. And we need to find the value of this expression given these values. What do parentheses mean? They're together to be considered as one term or one quantity, okay? So in this first, we want to find the value of each of these quantities by themselves. So what is the value of this quantity in parentheses? We have A plus B. What's the value of A?
7.
A is 4.
It's just thoughtless, lazy answering without thinking first, so that you can try to have the first answer, even if what you say is wrong and it makes you look silly because you don't believe that that's what the answer actually is. Stop trying to be first. It's more important to be right than to be first. A is equal to 4, B is equal to 3. 4 plus 3, 7. Nothing difficult. Nothing difficult. The second quantity marked by parentheses is A minus B. What's the value of A? Minus the value of B. What is 4 minus 3? 1. Now we have these two quantities standing side by side. What does it mean in algebra when two quantities are shown standing side by side?
Times.
Multiplication, good. Okay? So we simply multiply. 7 times 1 makes what? 7 times 1 makes 7. Is that the right answer? Yes. So we're through number, what, 9? 9. We have 10 minutes left? Okay, let's keep going. Number 10 is a big one. You guys should have fun with this. Now, I'm not picking on you. Do you understand? I'm not picking on you. What I want you to see that should actually make you excited and hopeful. Look at me a second. I'm showing you that the things that you get wrong are dumb, right? They're really not serious problems. If you just fix these things, they're just bad habits. And if you can break these bad habits, learn to be more careful, go back, review all your arithmetic facts, clean these things up, and get your act together, there's no reason why you can't do very well in algebra. Algebra is not hard. The stuff that you're getting wrong is just simple mistakes that you can easily fix up. You understand that? All right, number 10. Number 10, we have x squared minus 3 times a plus x. Check what I write, make sure everything is accurate. Times the quantity a minus x plus the quantity 2by. Now, do you notice that the expressions are getting more complicated? They're getting more complicated. Every expression gets a step more complicated and builds on what you've learned before. And this is why I warn you, if you're not careful in the beginning, it just builds and it gets more complicated. But if you stick to the principles and the definitions, it's not difficult. What's the first thing we're going to look for? We're going to find the terms. Okay? What's the first term we have? X squared, right? Now we've got this big mess. We look at that and we say, ay, 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 what do I do with this big mess? The first thing we're going to do with it is look at it with an algebraic mind. All that this is 3 times some quantity times some quantity. Do you see that? If I wrote 3 times b times c, would you understand what that means? Would you understand that? 3 times b times c? That's all that this is. Okay? It's 3 times another quantity times another quantity. So this is our second term. Do you see that? It's 3 quantities side by side that are multiplied together. Do you see that? And this here is our third term. There's 3 terms. X squared, this term is equal to, what's x equal to?
2.
And what does x squared mean?
Second times itself.
Right, times itself. Good, so 2 times 2. So what's this quantity equal to? So our first quantity is equal to 4. 4 minus, now let's look at this big monster. What do parentheses mean?
It stays together.
Keep them together as a quantity, as a term. Okay, even though they're separated by plus and minus, we're going to keep them together. So what we have here is minus, I should put it, yeah, I'll put it here. 3 times the quantity a plus x. So what is a? 4 plus x. What is x? 2. 4 plus 2 is 3 times 6 times, what's the value of a? 4 minus the value of x.
2.
What's that quantity equal to?
2.
2. Is that complicated? That's all that says. But you know what the danger of algebra is? A lazy kid will look at that and go, you see what I mean? Just be lazy because it looks complicated. But if you just take it apart piece by piece, it's not complicated. You just have to take it apart. That's called analysis. You just have to take it apart. So what's 3 times 6?
18.
What's 18 times 2?
36.
The value of this second term is 36. And we're going to add to this the third term. What's the value of b?
3.
What's 2 times 3?
6.
What's the value of y?
6.
What's 6 times 6?
12. No.
Did you just say 12?
No, I was 3.
That's like the 4th time. What's 6 times 6? 6 times 6 is 36. So we're going to bring this down and plus the third term, which is 36. Now, what you'll do is you'll say 4 minus 36, and you'll say, oh, I don't know. What's 4 minus 36, do you know?
32.
Negative 32. Negative 32. If you have $4 in your pocket and you lose $36, how many dollars do you have in your pocket? Not only do you have not the 4, but you also lost 32 more, right? 4 minus 36 is negative 32. What's negative 32 plus 36?
4.
Positive 4, right? So the answer is 4. Is that the right answer in the book? Yes. But look, I just want to show you something. Nobody would actually do that. Okay, we're going to stop. Nobody would actually subtract 36 and add 36. Just look at this. That's pretty dumb, isn't it? To take away 36 and then add 36. So if there was a pile of rocks and I said, what I'd like you to do today, your job is to take out 36 stones, and then your job is to put back 36 stones. Right? Wouldn't you just say, hey, can I just like not do anything because it's the same thing. So when you see something like this, where you're asked to do opposite operations that have the same value, you just ignore them. There was the answer. Right? You don't have to take away 36 and add that. That's a waste of time. It just brings you back to the same value. So the answer is 4, and that's the correct answer to the number 10. All right, so time's up for us. That's an hour. We've had a fun little journey through the first 10 exercises in algebra. What's really helpful about that, I know you can get embarrassed when you make a mistake or you say something that you regret, but what's important is, do you see the kinds of mistakes students make in algebra or in math? Do you see the kind of mistakes? Can you fix those mistakes? Can you fix those? Yeah, I mean, it's not like there's some serious problem. It's not like this is some mystery language that you can't decipher or you can't understand. The things that you got wrong have nothing to do with algebra. Have you seen that? Have I convinced you of that? That the things that you got wrong have nothing to do with algebra. They're actually moral problems that you have to overcome to be good students. You have to learn to think before you speak. You have to look something up if you're not sure. You can't be lazy. And then secondly, it's just careless errors. And it's errors in arithmetic facts, which there's no excuse for those. You have to master arithmetic facts. Okay? So it's good. It's good for us. It's like going to the doctor and the doctor gets to see what your problems are, right? Except you guys also got to see what the problems are. You see what your weaknesses and faults are, and now it's up to you to fix them. And if you fix those faults, you can do great in mathematics, in algebra, and even higher maths. So take a minute. I want you to write a summary of what we did. And in your summary, I want you to include the errors that you saw us make as we worked through these exercises. Errors that you're going to pay attention to and make sure that you don't commit again. All right? And that's all for what's now our first part of lesson 4.